Today I will be comparing a nucleosome protection assay and a northern assay. Both of these tests can be used to assess transcription activity in a cell. However, both of these assays use different mechanisms and are looking for different things. For an example, say you are interested in looking at oxytocin transcription. If I were to run a nucleosome protection assay, I would be able to see if transcription is occurring in isolated DNA from different cell lines. This is going to be measured by the degradation of DNA by DNase. The presence of histones protects DNA from degradation, but when histones become acetylated or phosphorylated, as in the case of DNA ready to undergo transcription, the chromatin will become less condensed, leaving the DNA more susceptible to degradation. So in my example here, I took DNA from the paraventricular nucleus of the hypothalamus, where oxytocin is synthesized, and a red blood cell. I sliced my DNA using restriction enzymes where the oxytocin gene would be, and ran a nucleosome protection assay. Because oxytocin was being actively transcribed in the DNA of the neuron, there is going to be no DNA present in the nucleosome protection assay as the DNase degraded all of that DNA. However, in the red blood cell, because the chromatin was still condensed, indicating no transcription, it protected the red blood cell's DNA from degradation by the DNase, hence the presence of DNA on the nucleosome protection assay. You can also measure transcription activity by looking at the end product, or mRNA, which is what a northern assay is going to do. So say I am still interested in oxytocin, and I isolate RNA from a red blood cell and from a neuron in the paraventricular nucleus of the hypothalamus again. I again am going to use restriction enzymes to specifically look at the oxytocin mRNA. And I'm going to run both of the isolated mRNA on a northern assay. In the neuron, I would see the presence of the oxytocin mRNA because transcription actively occurred and mRNA was synthesized. However, in the RNA from the red blood cell, I would see no RNA present because no RNA was synthesized from DNA. This was over the span of 48 hours, so if I were to, say, increase that length of time to 96 hours, I would see more RNA present from the neuron because more transcription occurred and therefore more RNA was synthesized. So in short, both of these assays are going to be able to measure transcription activity in different cell lines. But whereas a nucleosome protection assay is looking if DNA is actively being transcribed, a northern assay is going to measure the end product of transcription, mRNA.